Hello students. In this lecture, we have soil structure as a topic which comes under the soil physics branch. We can learn it in detail. So this is JRF soil science classes about soil structure part 1. And in this lecture, I am going to discuss in detail about the definition of soil structure, how it is formed, that is its genesis, the factors influencing the genesis and types of aggregates, soil structure and pore space, soil structure and water flow. And these five topics are covered in part one of this video. Part two of soil structure topic will be dealt in another video. So these topics come under the part two video. Now look at the picture. There's a huge lump of soil, right? You have seen everywhere. Under natural condition, we can't see sand, clay, or silt in a single particle form. We can see this form only. Is it? So this lump is known as aggregate of soil particle. Uh, you all have heard or studied about the PED, PED. Is it? You all know that it is a unit of soil. Another name of aggregate is another name of PED is aggregate. So look at this picture. What happens here is that various soil particles are cemented together by some binding agents and are also subjected to various physical, chemical, or biological process to form this type of aggregate. This is the aggregate, soil aggregate. So this is the another name is secondary particles. So primary soil particles like sand, silt, or clay will not exist in natural condition but are bonded together to larger units or aggregates, usually termed as secondary particles. So secondary particles means this one, soil aggregate. So these primary particles are grouped into aggregates like this. Then we can call it as a soil structure. In simple words, it is the arrangement of these primary particles into secondary particles in certain pattern. Okay. The water and air circulation in the soil varies according to the structure mainly. The soil structure is the arrangement of primary and secondary soil particles in a certain structural pattern. The first and foremost characteristic of a healthy soil is the this one, good structure. So this is the first and foremost characteristic of a healthy soil. It should have a good soil structure where water can move easily through the soil pores. Healthy soil have high amount of organic matter, so it looks darker in color. Whereas all these characteristics are opposite in the degraded soil, as we can see in the picture. So the main reason for this poor structure or water infiltration, erosion, etc. in degraded soil is that it has a weak structure. Okay, we have to know how this soil structure is formed. So we can see the genesis or formation of this soil structure in detail. So there are two processes is involved in the genesis of soil structure. They are flocculation and second one is cementation of floccules. Cementation and first one is flocculation, next one is cementation. So for understanding the first process that is flocculation, we have to know one thing. Look at this picture, this one, this picture, first picture. That violet color, this central portion is a clay particle. So you all know that clay particle is negatively charged. Overall, it is negatively charged. So it will what it will do is that it will attract positively charged particles like water or any other ions like positively charged ions. So you see one word zeta potential. Theta potential measures how strong its negative charge is. This is of negative charge. So zeta potential measures how strong this negative charge is. So in a case, in suppose high zeta potential of that clay particle means strong negative charge. In that case, the clay particles. So two clay particles are when two clay particles are present. and this the two particles have high zeta potential, or this particle have high zeta potential. That means it has strong negative charge. It will repel each other. While if it have low zeta potential, it means less strong negative charge. Sorry, negative charge. So what happens is that clay particles come closer. That means they will attract each other. Okay, so at low zeta potential, clay particles will attract each other. When high zeta potential, clay particles will repel each other. With this, I am moving to the next slide. So the first process of soil structure formation is flocculation. Flocculation. It is an electrokinetic phenomenon in which positive and negative charges are involved. So in soil water suspension, the clay particles with high zeta potential repel each other. This is what I have already said. Okay. When we add a substance that is flocculating agent such as calcium and magnesium, zeta potential is lowered. The particles will come closer and attract each other, resulting in the formation of flocules of silt size. So what happens is that when we add flocculating agent, zeta potential gets reduced. So the clay gets attracted each other. It forms flocules. So this process is known as flocculation. So the process of attraction, clay particles come closer and forming floc or flocules. It is known as flocculation. The opposite of flocculation is dispersion. Here, the particles will repel each other, and the flocules are stable as long as the flocculating agent is present. So, it also takes place due to dehydration, high soluble salt concentration, and presence of divalent or trivalent cation. So here in this flocculation, one force happens. The flocculation is because of the van der Waals force of attraction. You have to remember that this point also I didn't add in this slide, but you have to remember it. Van der Waals force is the primary cause of flocculation. So actually, when look at this point, flocculation takes place due to dehydration. That means when a soil dry, means moist soil means there is water between the clay particles. So when moisture content decreases, that means on drying, the contact between clay particles will increase because the water will be evaporated due to drying. So it will enhance the flocculation. Okay. One point also you have to remember is that the charge on clay particles will be negative. So it will attract cations and water molecule. Water molecule is polar. So it will be attracted to clay. And when this cation and water molecule will link to the clay particles and act as a bridge between the clay particles. So when the soil becomes dry, this bridge will be decreased. So clay particles will come close to each other, and this process is known as flocculation. And this is in simple words. Okay. The next process is cementation. Cementation refers to the consolidation of clay flocules by cementing material so that they may not get dispersed once these have flocculated. As flocules are not larger than silt size, therefore flocculation would be unfavorable for plants unless these are further aggregated by inorganic, like calcium carbonate, oxides of iron and aluminium, and organic matter cementing material. Flocculation of clay particles is a prerequisite for aggregation. Aggregation is always referred to flocculation plus, where plus is the cementing agent. So here what happens is that flocules are formed. So these flocules are binded together by cementing material present in the soil. So in this soil there are various roots and microorganisms will release polysaccharides. Then humus is also present in the soil, like inorganic and organic cementing materials are present in the soil. So they will act as a cementing agent. That means bridge between the clay particles or soil particles. Altogether, a big lump of aggregates is formed. So if there is no cementing agent is present in the soil, so formed flocules will be unstable. That means it will get dispersed. That flocules stability will not be there. So if the dispersion occurs, it will be unfavorable for the plants. So cementation is very important. So this aggregation means flocculation plus cementation by cementing agent. So this picture is all what I have said. So this is clay, this is water molecule, this is various type of cations like calcium, magnesium, this is polysaccharides, this is aluminum and iron hydroxide, which is known as the sesqui oxide. First, the flocules are formed. That means this is the clay floc by flocculation, by the process of flocculation, flocules are formed. And when sand and silt particles have a coat of this clay particle, then they will be binded together on their surface. So they get linked to each other, forming microaggregate. From the microaggregation by means of water, cation, polysaccharides, they will all the clay flocks are binded each other. Okay. So first flocculation happens and silt, clay, microbial debris, they all forms the what is known as microaggregate. Then these microaggregates are bounded together by fungal hyphae, then plant root, etc., forming macroaggregate. So this means other stabilizing agents with help of other stabilizing agent, fungal hyphae, this microaggregates will be converted to macroaggregate. Then this will be held together by the root. So when we pluck a root, we can see several macroaggregates on this root. So here you can see a macroaggregate consisting of clay particles joined together by organic matter, then silt and sand particle. Every soil separates are binded together. Okay, so uh, this formation of soil structure and its destruction which occurs in a cycle depending on many factors. Next, we can see the type of aggregates. So there are two types of aggregates, structureless and aggregated. First, we can see what is a structureless soil. In structureless soil, as the name suggests, there is no aggregation of soil particles or arrangement of particles into uh, bed or clump. Mm. So we can see the soil as a loose and non-coherent, which looks like a sand, like this. Okay, this looks like a sand. So example for this structureless soil is single grained soil and massy soil. So in single grained soil, it is dominated by sand particles, which is not which has no which do not have any sticking property. So they will not stick together. So no aggregate is formed. They are loose. Okay, this sandy particles, it is dominated by quartz. Hmm? So this quartz carry limited charge. So it is a primary mineral that carry a limited charge. That means less charge. So there is limited bonding. If charge is more, there will be bonding, but charge is limited. So very limited bonding and very limited flocculation happens in single grained soil. So they look like single grained. And another property is that it has very little clay. So no aggregation is found in single-grained soil. You can see in this picture, this is single-grained soil. Next is massy soil. This is massy soil. So actually it is a soil structure where this entire soil horizon, which appears as a single mass, coherent mass. We will say it as a coherent mass. We can't see any aggregates, any clump, like no visible pore or cracks are seen in this massive soil. So this is a typical of massive clay where the soil have high clay content or compacted soil, mm, or subjected to heavy traffic like heavy machinery. That type of soil is massive soil, so there is no visible aggregates, no visible pore or cracks. So when this type of soil becomes dry, they become very hard to break apart. This type of soil, we can't see any plant growing. Means it will be difficult for the plant to grow in such a massive soil because it lacks sufficient medium and large pores for the root development. Root anchorage, it will be affected, and also due to um, high amount of clay, very slow rate of water infiltration is seen in massive soil. Next one is aggregate soil. So in this, soil particles are associated in distinct aggregates or bed. This soil aggregates can be characterized in terms of their shape, size, and distinctness. So we can describe the soil structure of this aggregate soil based on the shape of aggregate, size of aggregate, or distinctness of aggregate. So type means according to shape and arrangement of this bed or aggregates, we have type of soil structure. According to the size of aggregates, we have class. According to distinctness and durability or strength of bed, we have grade of soil structure. So we can see these in detail in next slides. According the type of soil structure, there are four types of soil structure: plate-like, prism-like, block-like, and spheroidal. There are five classes of soil structure: very fine, fine, medium, coarse, and very coarse. And there are four types of grades: structureless, weak, moderate, and strong. So you have to study the characteristics of all this classification. Next, we can um, see types of soil structure. First one is plate-like. So here, plate. Plate means this one. This is the structure of a plate. You know. So here, the soil particles are aggregated into a thin plate-like structure. So they are um, like piled horizontally over one another. The single sheet we can call as a unit or bed. For the plate-like structure, horizontal dimensions are more developed than vertical as seen in this picture. So when size of bed is very thick, we can call it as platy, or when the size of bed is thin, it we can call as laminar. Sorry, there is a mistake. So this is the platy structure. So these plates will overlap on each other. So what happens is that it will restrict infiltration, percolation, and aeration status of soil. So in this plate-like structure, horizontal dimensions are more developed. When the pets are thick, they are known as platy. When pets are thin, they are known as laminar. So you have to remember these points. Next, we have prism-like structure. So here the soil particles are arranged into prism, a vertical column or like pillar. Look at this picture. Here some vertical cracks are also there. If cracks is formed, it will be vertical because of its the structure, prism-like or pillar-like structure. The first point to study is here is that its vertical axis is more developed than the horizontal axis. So it will give it a column or pillar-like appearance. So the vertical cleavage planes are predominant here. Here, this water and air circulation will be very difficult. Drainage will be also very poor because of this characteristic structure. When it is clumped together, it will be this water and air circulation will be restricted. So according to the shape of the top, this top portion, there are two types of prism-like structure. So When tops are angular, this one, when tops are angular, flat, and gives a clear cut, we will call it as a prismatic. But when the top is like this, rounded, when it have a rounded top, we call it as a columnar. So remember this, when the prismatic structure will have a flat top, it is known as prismatic, and while columnar structure will have a rounded top. Okay. Next we have block-like structure. So here all the dimensions are of same size. For a prism-like structure, the vertical we have seen the vertical axis was more developed. For plate-like structure, horizontal dimensions were more developed. But here in block-like, all dimensions are of same size. Okay, so we know what is a cube. Its all sides are equal. Like that, the block like in here, this ped or aggregates are arranged like a block or cube. So all sides will be of same size. All dimensions are equal. And look at this first picture, where this first picture, its face. Look at this face of all the faces. So here the face is flat, edges and corner are very sharp. So they are known as angular blocking. And here you can see the faces and edges are rounded structure. So they are known as subangular blocking. While so compared to prism and platy structure, they have a good drainage and aeration and root penetration, but to a little extent they are very good. Okay. So here you have to remember angular block and subangular blocking. Remember this picture. You can learn from this picture itself. Next one is spheroidal structure. As the name suggests, all the axes are developed equally. Means all the soil separates are grouped together in a small spherical structure. For a sphere, all the axes are developed equally and all dimensions are of equal length. So this spheroidal structure, all axes are developed equally and of equal length. And among this spheroidal structure, there are two types, granular and crumb. So in granular structure, it have less porous. It is less porous. That means its pores are less compared to crumb. Actually, all have a high porosity, but compared to crumb, granular structure is less porous, mainly because of low organic matter content. While crumb, it is highly porous. That means it has more porosity. So this is well suited for the agriculture. So this is an important point. So if any question comes like well suited soil structure for agriculture, you should choose this one, crumbly structure. Since they have many pores or high porosity, it will promote infiltration, percolation, aeration, root penetration in the soil. So that is why they are not well suited for agriculture. So this is granular structure, very porous, while this is crumbly structure, very porous. So this is the typical crumbly structure, granular or crumbly, spheroidal like structure, soil structure. Now we can look the realistic soil having granular structure. This is granular structure, this is blocky structure, this is platy, this is massive, and this is single grained. And this box is very important. First, platy structure. We will discuss more about it. First, this platy structure is inherited from the parent material, those laid down by the water, and it is found in the forest soil, and noticeable in the surface layer of virgin soil. It is formed due to compaction of clay soils by heavy machinery. So, just remember parent material, forest, virgin soil, compaction for platy soil. Then in prismatic, actually this prismatic and blocky structures are found in the B horizon, but prismatic it is found in arid and semi-arid region, in poorly drained soils of humid region having swelling type of clay. Then in natric subsurface diagnostic horizon, this begins study in soil pedology portion. Then blocky structure is found in the subsoil or B horizon. Maybe it will be found in A horizon also, but opposite of this prismatic. That means it is found in humid region, while prismatic it is found in arid and semi-arid, while blocky is found in the humid region. Both are found in B horizon. Okay. Only difference is its presence. First one, prismatic is found in the arid and semi-arid, while blocky is found in the humid region. Then next is spherical. Spherical is found in the surface horizon, that is A horizon. So this box is very important. Study it. So now we can look the next classification. It is according to the size. The soil structure can be divided into many classes. So for different type of soil type, there are different types of classes according to the size. So for granular, blocky, columnar, and platy, the diameter, that means size of aggregates, classification based on the size will be different. So first we can see granular structure. So it contains classes like very fine, fine, medium, coarse, and very coarse. While the uh, diameter is less than, if it is less than 1, it will be very fine. If it is 1 to 2 millimeter diameter, fine. 2 to 5 it is medium. 5 to 10 it is coarse, and greater than 10 it will be very coarse. Then in case of blocky, it will start from 5 millimeter, from very fine. So it will be increased in the multiple of 10, sorry, 5. Okay. And in case of columnar, it will be that classification starts from 10 millimeter. So this will be increased in terms of like 10 to 20, 20 to 50, 50 to 100, and greater than 100. But difference in is in platy structure. So in platy, we will call fine, very fine, or fine as thin. So instead of fine, we will call it as thin if it is 1 to 2 millimeter. If it is less than 1 millimeter thickness, we can call it as very thin. If it is 2 to 5, it is known as medium. If it is 5 to 10, we will call it as thick instead of coarse. And if it is greater than 10 millimeter, we will call it as a very thick class. Okay. So here you don't want to study all this millimeter. Just remember, according to the size, there are very fine, fine, medium, coarse, and very coarse classes of soil structure. Next is the grade of soil. So this is based on the strength. I already told it is based on the strength or durability of bed. So this strength is according to two forces: cohesion within the aggregates and adhesion between aggregates. It is a qualitative means of classification. So, in the second sentence, what I have to say is that different soil particles are joined together by cohesion within the aggregates. So, between aggregates, force acting is adhesion. Cohesion means the attraction between dissimilar objects. So within aggregates there are sand, silt, and clay. So what the force there acting there is cohesion, and between aggregates, all aggregates are similar. So adhesion between aggregates happens. So, stability, it is identified on the basis of stability of aggregates. Stability of aggregates refers to the resistance to disruption by impact of raindrops or under submerged condition. It is influenced by moisture content, amount and type of clay, nature of adsorbed cation, and organic matter content of the soil. So you see this point, it is influenced by the moisture content. So it is very important, means we should determine the grade of soil by taking the soil at moisture, not dry condition. Okay. So high moisture content, kaolinite clay, divalent cation, and high organic matter content make the aggregates relatively soft. So for making the aggregates, there should be high moisture content, presence of kaolinite clay, divalent cation, and high organic matter content. Remember this point. This is very important. And cohesion within the aggregates and adhesion between the aggregates. So there are four major aggregates. The first is structureless. So that comes under we first studied about structureless soil. So that only comes under this. So there is no observable. We can't observe the aggregation in structureless soil. Next is weak grade. So weak grade it is a poorly formed indistinct bed which are not stable. So actually, if we take it from the this profile, soil profile, and put it on the ground, it will be broken down into different aggregates because it has a weak structure or its strength is very weak. And second is moderate, means it is moderately developed bed which are fairly stable and distinct. So it has a moderate strength. Next is strong. It is very well developed pets which are quite stable and distinct. So this is the most strongest grade. That means if we take it from soil profile and put it on the ground, it will not break into it will break, but it will be very difficult for breaking into different aggregates, different particles. Okay. Next, what is the sequence for describing the soil structure? So we will follow grade, then after class, the type. For example, strong, coarse, angular, blocky. So here strong is a type of it is a grade of soil structure. Coarse is a class. That means it is based on it is a shape sorry size of the aggregate. And angular block is a type of soil structure. That means it is the arrangement of the soil particles into angular and blocky. So this